GIS stands for Geographic Information Systems. So what does this mean? Geographic refers to the features of the Earth's surface. And we usually think of this in terms of a map. Maps have been around for a long time. The earliest discovered map dates from a cave painting more than 13,000 years ago. Humans have long relied on maps to understand their surroundings and navigate the world. Maps began to be digitized in the 1960s, paving the way for the development of GIS. But what makes GIS more than a digital map is the addition of information. A traditional map can convey a limited amount of information. Labels can be added, and certain information can be given through the use of colors and symbols. However, with GIS, geographic features can store any amount of information or data. Take this pipeline map as an example. In GIS, each pipeline segment can hold detailed information or attributes, such as a unique identifier, commodity the pipe transports, diameter, length of the pipe segment, company who operates the pipe, when the pipe was installed, and maintenance details. This information can be stored, updated, and retrieved in real time, making GIS a dynamic system. In fact, some GIS systems operate live, displaying real-time data such as current weather patterns, traffic conditions, or the location of ships and aircraft. GIS combines geographic data with a database, creating an integrated system. This system not only allows us to visualize geographic features, but also provides easy access to the associated data. Users can interact with the map by selecting features to view detailed information, or they can search directly within the database. But GIS is far more than an interactive map. Because we have an associated database, we can perform analysis. This is called spatial analysis, and this can give us valuable insights and answer questions. GIS is typically a layered system, where datasets represent something in the physical world. Layers can consist of vector data, which maps physical features using precise coordinates, or vectors, in the form of points, lines, or polygons. Examples include roads, buildings, or boundaries. Alternatively, layers can be composed of raster data, which represents continuous data, such as satellite imagery, elevation models, or weather patterns. Raster data is made up of grids or pixels, with each cell containing a value that reflects information, like intensity or measurement. Layers can be added, removed, or combined depending on the task at hand. For instance, in an urban planning project, a transportation layer shows roads, railways, and transit routes. Other layers could represent population density, land use, or the location of residential, industrial, and educational facilities. A utility layer might display water, waste, and power lines. Physical layers might include topography and flood zones. Together, these layers form a detailed model of the real world. By analyzing the spatial relationships and data within these layers, GIS helps to answer questions. For example, in this 2016 study of a city in Malaysia, the areas most suitable for further urban growth was determined. Factors such as socio-economic criteria, population density, and the physical environment were considered. The final output can be seen here. It shows areas of suitability for further development, with the most suitable in red and the least suitable in green. Spatial analysis like this can help drive decisions and policy. GIS has seen dramatic increase in use over the last couple of decades, and it is a growing industry. GIS can model the world in 2D and 3D, or a combination of both. It is widely used by government organizations, NGOs, and private enterprise. Any institution or organization who needs to model the physical world are mostly using GIS. The fields GIS is used in are widespread, from urban planning, as we've seen, to the military, environment management, mining and resource exploitation, understanding crime, and many others. So, how are GIS systems hosted? Is Google Maps GIS? Well, not really. While it does have some of the elements of GIS, like data and visualization, it has limited control of the underlying data and cannot build a database and perform detailed spatial analysis. Rather, Google Maps is a web-based mapping application rather than a professional-grade geographic information system. However, there are many providers of GIS software that makes these systems possible. There is the open-source, free-to-use QGIS or the commercial ArcGIS, these two being the most popular, but there are a number of others. They all work in slightly different ways, but the end goal is the same: to provide users with a geographic information system. With the rapid advancement of technology and an ever greater availability of data, the role of GIS seems likely to increase, at least in the foreseeable future. GIS is becoming an increasingly integral tool for managing assets, advanced spatial analysis, and informed decision-making across various sectors. And if you'd like to learn more about GIS, follow this channel for more discussion and tutorials.